Hello fellow Heathkit users and other hobbyists who are interested in robotics. What I'm going to show you here today is how you can upgrade a Hero 1 robot built around 1983 to use newer technology. One of the things that makes this Hero 1 robot so interesting is that its construction exceeded its expectations for the time. It was way ahead of its time. The Hero 1 is actually a precision 3D printer that runs on wheels, if you think about it that way. It has 7 unipolar stepper motors, and some of them are driven with gearboxes, giving it very accurate positioning. What I propose to show you in this video series is how you can upgrade the Hero 1 robot to use newer technology, and we're going to start out with the easiest upgrade, I think. One that doesn't require any changes to your Hero 1 robot itself. And really you need a working Hero 1 robot to do this upgrade at this point, because it uses all the original PC boards and the microcontroller, the 6808 microcontroller. But what it does is it allows you to remotely control the Hero 1 robot using what's called a VEX game controller that has Wi-Fi or VEXNET, I believe it's called, that's used in contests all over the world for VRC, FRC, FIRST, and STEM contests. Here's the VEX game controller. It's built by Innovations First Incorporated in Greenville, Texas, and it's a very well constructed game controller, very similar to the Sony PlayStation controller. It has 2 joysticks and 12 push buttons. 4 of them are in the front and 8 of them are on the top of the controller. And the little box sticking out at the bottom is the Wi-Fi key that integrates to the VEX Cortex microcontroller. This is the front of the VEX game controller. As you can see, it has 2 groups of 4 push buttons, one on the left side and one on the right side, and as well as 4 push buttons on the front. Here you can see the 4 push buttons on the front. The main part of this upgrade kit, which I'm selling on eBay, is this VEX Cortex microcontroller. It is also used by students all over the world in VEX VRC competitions as well as FIRST and FRC competitions to control their robots. There's a newer version of this called the VEX V5, which is much more expensive, and it's a little bit harder to use to do upgrades. But the VEX Cortex is ideal. It allows you to just use jumper cables, and you just plug them into the digital input port that you can see on the left side there with the wires coming out. The wires are connected to a 15-pin Molex connector that adapts to the original Hero 1 Teaching Pendant port. Again, it's a 15-pin Molex connector, but I've also used just nails sticking into the Molex connectors, and just soldering wires to that, and that worked too. So you can use whatever means you have to make the connections. The important thing is to use the schematics that I provide in my article for the correct wiring. It's critical that you make the correct connections, otherwise you could short out one of the circuits. It does, the teaching pendant did use 5 volts, but the VEX Cortex doesn't require that 5 volts wire. It just requires the signals coming from the digital outputs of the digital inputs of the Hero 1 robot's teaching pendant, as shown in the schematics that I provide in my article. I sell a complete upgrade kit that has all the software pre-flashed onto the VEX controller. At this time I don't sell the actual source code. I only sell the pre-programmed VEX Cortexes with the application. And the kit itself, the do-it-yourself kit, requires you to just make the wiring as shown, and then just plug it into the Hero 1 robot once you assured yourself that it's correct. Here's a top view of the VEX game controller, and you can see the paired VEXNET key. The kit that I provide has two keys, one on the game controller and one on the VEX Cortex microcontroller, the one shown here. You need these two keys to be, you need the key on the game controller to be paired with the VEX Cortex, otherwise they won't communicate. I do that before shipping any of my kits, and I test them to make sure that everything is working correctly. Now I'm going to move the Hero 1 around using the original teaching pendant. This is a quick demo showing you the Hero 1 moving around under control of the teaching pendant, which is tethered. This again is the original black teaching pendant shown a little while ago. Okay, I've activated the Hero 1 robot, and now I'm going to first home the motors. This is an operation that basically resets all the stepper motors to their home positions, as well as the main drive motor. You can see the head turning. It's going to turn till it reaches its limit switches on the left and right side, and it uses that to determine the home position of the head stepper motor. Now it's homing the steering, again hitting the limit switch on the extreme side, as well as the wrist and the wrist pivot and the wrist rotate motor.
Ready.
And the robot says ready when it's completed its task. The homing operation is important even when you're using the VEX game controller. You should home it initially to start with, just to get all the motors to their mid positions. Now I'm going to plug in my VEX Teaching Pendant Emulator. That's what I call the application that runs on the VEX Cortex. It's the firmware that I wrote in Robot C. Robot C is usually used on the VEX Cortex to develop applications. It's a pretty powerful C language, and it even allows you to do multitasking. So it's very good for robotics. Has a lot of support for robotics. And all this support can now be used with the Hero 1 robot. Okay, so this is the teaching pendant that I emulate. As you can see, it has a rotary switch, and then it has a switch for switching the arm and body functions, and then it has a motion left or right. That's how you can steer the robot. You can turn it left or right, and that's also how you can turn the head left or right, clockwise or counterclockwise. In addition, it has a trigger that you have to press when carrying out all these actions. That actually makes the motors move, this trigger right here. In order to put it in its training mode, you press 4, which is the learn mode, or the teaching pendant mode on the Hero 1 keypad. Just did that. So now it's in the learn mode. First operation I'm going to try with the original teaching pendant is to rotate its head. So I turn the rotor switch to the head position, and then I put the body arm to the arm position, and now I can turn the head clockwise or counterclockwise. And it's very precise. It's a geared motor, so it can move very precise increments. Again, this is 3D printer stepper motors. Although they're not as they don't have the resolution of a 3D printer, they're still very accurate, especially when you use the gearboxes. Okay, now I'm going to move the robot forward or backward using the main drive motor. I'll just move it straight. So to do that, I switched the arm body function to body, and now I can move backwards by having the rotary switch on the reverse side, or I can move forwards by switching it over to the forward side. So and then I can go back. I can also turn the motor. So you see the steering turning. And I can do that while moving forward or backward too. Here you see the back side of the Hero 1 robot showing the robot arm, which I'm going to move a couple of the motors for you, just to show you how it works. So now I'm going to put the switch, the function to arm. So now it's going to move the arm motors, and I'm going to try pivoting the wrist. See, it's pivoting the wrist. And that is very powerful. It can pick up chess pieces pretty accurately. I've been able to pick up chess pieces on a board and move them around. And with this teaching pendant, you can actually train the robot. You can teach it these positions and then record all the motions, and it'll save them in memory so that you can play them back later. Unfortunately, the Hero 1 doesn't have very much memory, so it can't store too long a motion script. I'm working on a different upgrade that increases that memory to use practically any length motion scripts using megabytes of memory. Now I'm going to rotate the wrist. You see the wrist rotating. It's pretty good considering this robot was built in around 1983, so it's close, it's quite a few years old. I built this robot with my brother. It took us a few weeks to build it. I remember soldering all the boards, and he did all the wiring. It was an amazing task. We got this robot as a gift from my father to help us get through college, to learn electronics. And I guess it did help me. And it helped my brother too. The arm can be extended or retracted. So right now I'm extending it to reach out for, let's say, a piece on the far side of the chessboard. Although it's slow, it moves with precision. Then I can retract it. The design of this robot arm, even though it's got a plastic case, the case was pretty rugged, but if this arm had been made with a steel shell, it would be very robust, and it would be able to pick up very heavy objects. As it is right now, it can only pick up objects it can pick up a can of soda and hand it to you. That's about the weight that it can handle. Now my upgrade again plugs into the bottom 15-pin Molex connector that you can see shown right here. There you can see the main power switch that switches power to all the motors and electronics. It gives you the plus 12 volts and also the plus 5 volts needed to run all the TTL circuitry and the 6808 microcontroller. And also you can see the two batteries on the bottom. These are just 12 volt SLA batteries. I replaced the original ones with these that you can buy at any battery store. They usually use for alarms and things like that. And there's also another 6 volt battery on the head of the robot. So the kit that I'm selling is basically just the Cortex that I showed you with the adapter hooked up to it, which you can build yourself out of your own parts and just hook them up to the VEX Cortex. You can just use standard jumper cables, the kind that you use for prototyping kits like Arduinos and and Raspberry Pis. And then just basically either get a Molex connector, you need a male connector, or use just nails stuck into the connector there, as long as you don't short them out. You got to be very careful not to short any of the pins. And of course you can just coat the pins with rubber tubing just to protect them from shorting. Alright, I just plugged in my VEX Cortex Teaching Pendant Emulator, and I plugged it into the Teaching Pendant port on the Hero 1 robot, as you can see. The next step will be to power the VEX Cortex, and for that I just need a standard battery, or I use an external power supply. The VEX Cortex is usually use a 7.4 volt NiCad, or the RC type batteries. And Innovations First Incorporated sells them specially made for the VEX Cortex and VEX EDR systems. I just powered up the VEX Cortex microcontroller. You can see the lights are flashing, which means that it's waiting to be synced with the VEX game controller shown here. So I'm going to turn on this, and when I turn it on, the lights will be orange, blinking orange, until they sync, and then they should all turn green on both the VEX game controller and the VEX Cortex. Okay, one of the lights turned green. Okay, now they're all three green. Perfect. Now I can start remotely controlling the Hero 1 using this Teaching Pendant Emulator app that's running on the VEX Cortex. In order to use the VEX game controller, I had to map all the buttons on it, and as well as the joysticks, so that it would emulate the same function as the original Teaching Pendant supplied by Heathkit. So you can see here that I mapped all the buttons and functions so that they simulated the rotary switch, the arm body switch, and the trigger switch. The trigger switch is one of the front buttons on the game controller. It's the top front button on the left side, 5U. And then I have a stop button, so a stop button will stop all the motors. It'll be the equivalent of putting the rotary switch into neutral. Right now I'm limited to very short movements because my battery for the Hero 1, for the VEX Cortex died, so I need to get another battery. But right now I'm using my own power supply that supplies 9 volts to the VEX Cortex. You can supply anywhere from 7.4 volts to 9 volts, and there's no problems. But I would not exceed 9 volts or 9.4 volts. You can use the VEX 9.4 volts batteries that they sold that were used for their remote control, their older RC controllers. Alright, I'm going to start by trying to move the head, and this is being moved via Wi-Fi. Now the range on this is probably close to 30 to 40 feet, as long as you don't have interference from other remote controls that are using Wi-Fi. So as long as there's no noise or anything, you can, line of sight, you can probably control something to around 30 feet with this controller. So this gives you quite a distance that you can control your Hero 1 robot. And again, this is a very simple upgrade. It's just a matter of a controller, a couple wires hooked up, and then the firmware that I developed. You just saw it move backwards. Now move forward. Again, I'm doing this all from the VEX game controller. In order to move the head, I have to use the 7 up button, as well as the trigger and the left and right switches to move the head left or right, or to move it clockwise or counterclockwise. Okay, this is a front view of the robot. I've blocked it up so that I don't accidentally move it forward and backward with that power cable, because I almost had an accident disconnecting the microcontroller when the robot moved. For the following remote movements, I'm just going to use the head and arm, so I don't really need the main drive motor. So here I can turn it clockwise or counterclockwise. Again, here I'm moving the head. Very precise positions. Now I'm doing the steering. See how smooth it can turn the steering. Now I'm going to show you how I can move some of the ARM motors. For an operational version of this upgrade, the VEX Cortex would need to be mounted on one of the sides, probably the back side that you see there, and just mounted against the power board probably. Being plastic, it won't short anything out. So you could just sort of mount it with some screws or some double stick tape or some spacers, whatever hardware you happen to have that would hold the VEX Cortex, and so that when you put the sides on the robot, it wouldn't interfere with them. You have to be very careful with the wires. You probably should encapsulate them in tubing, shrink tubing, or just tie wraps. Here you see me opening and closing the gripper. Now I'm going to pivot the wrist using the 8 right button. See, I can pivot it. Again, this is very accurate positioning. I've used this robot to play chess against another Hero 1 robot, and it's been able to move the pieces under control of the teaching pendant. Now I'm going to extend and retract the arm using the 7 down push button on the VEX game controller. You can see it go down very precisely. That's a directly driven lead screw motor, so it gets very accurate positioning. You can even use this to play cards, like blackjack. Have 2 Hero 1s playing blackjack with each other. This upgrade really opens up the capabilities that the Hero 1 can do. It can perform many more tasks now with just this very simple upgrade. I'm working on another upgrade for robots that don't have any, the electronics aren't working at all, or the robot just doesn't work for bad power supply or bad motherboard, and you know, these boards are very rare. They're very hard to find and expensive. They can be found on eBay, but the components are just getting older and older. They use basically a lot of TTL, and some of those go bad just from static or background radiation even. Alpha particles can do damage to them, and of course they're very static sensitive. It's amazing that all the boards on this robot are still working. This is the one that I built with my brother. In fact, I'm kind of proud of this robot because I did all the soldering on those PC boards. So, you know, it's amazing to me that this is still working. I mean, how many people have a TV from the 1980s that still works? You know, they usually go very quickly. The newer TVs with the LED, bright white LEDs, burn out when capacitors dry out, and then you have just a gigantic sheet of glass in your home. So this robot was built very well. It was very well designed. It's very robust, very rugged, and the motors and everything were built for precision. I mean, this is really a precision instrument. The upgrades that I'm working on now for robots that are broken will include using my own design of a unipolar stepper motor driver board that can micro-step the stepper motors using the 3D printer technology. So you can micro-step them to 1/16 of a step or with the unipolar. And then I upgraded another Hero 1 robot to use a bipolar stepper motor controller. This is the one that's actually used in most 3D printers sold to hobbyists. But they're very precise, uses the Ramps 1.4 board. And that can micro-step the stepper motors to 1/32 of a step. So doing that, you can have a Hero 1 robot performing surgery. That's how accurate it is. I mean, when I was micro-stepping the rotation of the wrist and the gripper, I thought at first that the thing was just dead, but I had accidentally set the settings for 1/32 of a step instead of 1 step, but then I saw it slowly turning. It was like an astronomical instrument. It's really that precise. So when you're micro-stepping, you're getting incredible resolution, like with the head movements and the arm movements of this robot. So I wouldn't doubt that you could even do drawings and, you know, like on a piece of poster board, a white poster board, you could have the robot draw like spirographs very accurately, just like a printer. Because the steering motor is also a stepper motor in this robot. Again, very well built, and definitely worth upgrading especially if you have a robot that still works and all the boards are working just like this one. Then it's very simple to have it start working with a Wi-Fi or VEXNET as they call it. And so you can demonstrate it to your friends and run it untethered, so you don't have to have the black teaching pendant with you. The only disadvantage is that right now you can't really train it, you can't really store those positions, but the newer upgrade that I'm doing, you'll be able to store the precisions. I've been able to have it move chess pieces autonomously. It's that precise. You have to home it, and you have to get the stepper motor counts back. And that's one problem with this upgrade. You don't get the stepper motor counts back. The only way you could do that is if you probably used the robot interpreter and have somehow read back the stepper counts, or you could use the Wintec Robot Basic that came with as an upgrade to the Hero 1 and have it report back the motor, some of the sensors. Maybe it would report back the stepper motors. Positions. I don't know. I thought you could only just give it like an angle and it would just move it that angle. But actually, if you could use the Wintec to return the ultrasonic ranger that the Hero 1 has, you'd be able to do some ranging as you're moving the robot around. So you could, if it's going to hit an obstacle, it could stop the motors, you know, that kind of thing. To do that, you'd have to read the Wintec, the sensors through the Wintec Basic, and take that telemetry and incorporate it into your own controller. What I've been doing for the new upgrade is to use a Raspberry Pi 4. My previous upgrade used a Raspberry Pi 3, and that was powerful enough. But since I have on a Raspberry Pi 4. I decided to use that, and you know, that's going to be an interesting upgrade. I'm going to do some video clips of it as soon as I get them done, and I'm going to have some boards that you can actually plug right into a Hero 1 robot that doesn't work. What you do is you just remove all the previous boards and you carefully save them. So it's a non-destructive upgrade. You don't do any wiring changes or anything. So in fact, you could even take a working one, although I would only do that if I was really confident, you know, of my skill levels. Because you know, but then again, unplugging these boards and plugging them back in sometimes gets the boards working, because those contacts corrode over the years. So in fact, removing the boards and cleaning the contacts and then putting them back might get your robot working again. That's happened to me. I've just cleaned the contacts, removed the board, cleaned the contacts, and pushed it back in carefully, and the thing worked. So the new kit is going to allow you to remove all the boards, carefully pack them away. So if you want to restore the robot to its original condition, you can. And then you'll be able to plug in the new boards that I've designed, which include a unipolar stepper motor controller board and a PWM DC motor controller board. And they're all controlled by a Raspberry Pi and 2 VEX Cortex microcontrollers. One is a VEX motion controller, and the second one is a VEX sensor controller. And this allows you to use all the VEX EDR sensors that are available, you know, that are students use in contests and everything. So you could plug in modern sensors, modern ultrasonic rangers, modern LiDAR. You know, in fact, with the Raspberry Pi 4, you could put in a LiDAR. That's one of the upgrades I'm thinking of doing for the sensors end of it. That's all in the future. I'm working on those upgrades now, and keep an eye out for them. And please follow me on this channel and like this video if you found it interesting. And I'll keep posting new videos of upgrades as they go along. This was part 1 of this video session. Thank you very much. Bye.